What is up, young chemists? Mr. Rosen here. This is going to be a demo of potassium permanganate and glycerin or glycerol. And what I've done is I have poured some of the potassium permanganate into a Dixie cup. I have about 5 grams of it. And this is what it looks like. So it's a dark gray. Right now it's kind of a powdery solid. And I'm going to put that into an evaporating dish. And this is it in the evaporating dish. And then I have the glycerol. And it is a liquid here at room temperature, clear liquid. Now I'm going to use this this little pipette dropper, and I'm going to draw some of it up, and then I'm going to put it on top of the potassium permanganate. Now I'm going to do that inside of a fume hood. So just to kind of show you the setup here, this is my classroom, and this is a fume hood. We can do reactions inside of it and then hit this switch and it will pull air out through the top. So I'm going to put this here. Now the reaction might take a little bit to get going, so I want to start the reaction and then we'll come back and revisit the properties of the reactants. So you have more time to fill those in, but I just want to get this going for the sake of the video. And then we also might like fast forward through it, but this is, try to focus it a little bit. You can see in here some of the glycerol, and I'm going to add it to the potassium permanganate. And that should be enough. Alright, so there we are. Now, like I said, that might take a second, so I'm going to just come back here and we will return to our 2 reactants. So the first reactant is potassium permanganate, and they ask what the chemical formula is. You can see right there it says K, that's the potassium, Mn, that's the manganese, and when it's MnO4, that's actually a polyatomic ion, permanganate. So KMnO4, that's potassium permanganate. And as we said, it is a sort of a grayish black powder. So that's a little bit, you saw the physical properties of it. And our glycerol is here with a chemical formula, C3H5OH in parentheses 3. So it has 3 OH groups. Now, as you can see, it is a liquid at room temperature, but it's, you might describe it as like being thicker than water. The ability of a liquid to flow, the more scientific term for that is viscosity. It's more viscous than water. It looks something closer to like a olive oil or something like that. Not as viscous as something like honey or molasses, but still pretty viscous. So it's a clear liquid at room temperature, and that is our chemical formula. So, like I said, I put about 5 grams of the potassium permanganate into the evaporating dish, and then I added the glycerol to it. And right now it's in the fume hood, and we're looking for any signs that a chemical reaction has occurred. So far, doesn't seem like much is happening, right? And you might wonder, well, did we get a dud? This is why I wanted to start it and let it go for a little bit. Whoop, whoop, whoop. I'm gonna start the fume hood. You might hear noise. Back up. I don't know how loud that is on the camera, but the fume hood, it's got a powerful fan, so it sucks all the gas that was released up out of the classroom. It's also a good thing. Got my goggles on. I don't know if you heard that, but when it was reacting, it was such an exothermic reaction. Got so hot so fast that it actually cracked my porcelain dish. I could hear it crack when I was in here, and I don't know if we're gonna be able to see it, but right here, starting right there and working its way down. See if I can get, you can kind of hear it. Yep, there you can see the crack running right along here. So this porcelain dish is, it's done for. It's very hot. And you can see some of the leftover products in there. And this is very hot. Not gonna touch that for a while. So, kind of a cool thing to think about. We have just a kind of a black solid, and I just poured this liquid on top of it. And that was the reaction that occurred. It was the reaction of potassium permanganate with glycerol. Chemistry. For the win.